Okay, this video accompanies the 6-3 notes. I guess guided notes on parallelogram properties. So let's take a look at these. Throwback warm-up. Suppose these lines are parallel to each other. Let's look at 6 and 15. Angle 6 and angle 15 are examples of alternate interior angles. 4 and 13. Now 4 would be congruent to 5, and 5 would be congruent to 13 because of corresponding angles. So alternate interior angles and then corresponding angles. Correspond, C-O-R-E-S-P. So those are the two ways that we could get those congruent. And 4 and 11 being supplementary, same side interior angles are supplementary. AIA angles are congruent. Okay, so there's the warm-up part. Parallelogram is a quadrilateral with both pairs of opposite sides parallel. To name a parallelogram, we can use a symbol, parallelogram symbol. So we could say in parallelogram, ABCD. BC is segment BC is parallel to segment AD, and segment AB is parallel to segment DC. If a quadrilateral is a parallelogram, then its opposite sides are congruent and parallel. Its opposite angles are congruent. It's consecutive. Angles are supplementary. So opposite angles are congruent. Consecutive angles are supplementary. So these two angles going to add to 180. These two going to add to 180. These two going to add to 180. These two going to add to 180. But in terms of opposite angles, they're going to be equal to each other. And those opposite angles are going to be equal to each other. The opposite sides are parallel and congruent to each other. Parallel and congruent to each other. So let's look at this. If we, in a parallelogram, throw a right angle in at one of the angles, then because consecutive angles are supplementary, if this is a 90, this has to be a 90, this has to be a 90, and this has to be a 90, or opposite angles have to be 90s, and then supplementary, and then opposite angle 90. But one right angle can force all the angles to be right, which gives us what we call a rectangle. So a rectangle is a parallelogram with a right angle, and that means all right angles are going to be in the rectangle. Let's look at these examples. So we want to find these different lengths. Opposite sides are congruent. That's going to be 4 feet. Opposite angles are congruent. That's going to be 45 degrees. Same side interior is supplementary. That's going to be 135 degrees. Opposite angles congruent. That's going to be 135 degrees. Opposite sides congruent, 1.5 feet. So CD is 4 feet. Now, if units are given, you should use units. Measure of angle B, 45 degrees. Measure angle A, 135 degrees. Let's look at this next one. So let's see. If this is a 7.5, opposite side is 7.5 centimeters. Opposite side 3.9 centimeters. This is a 59. Opposite angle has to be a 59. Consecutive angles are supplementary. This is going to have to be 121. And then this one's going to be 121 because it's an opposite angle. So we've got that pretty much solved. RS is 3.9 centimeters. And measure of angle R is 121 degrees. It's gone. Now, in a parallelogram, the diagonals bisect each other. In a regular parallelogram, like a rectangle or a square, the diagonals are going to be congruent to each other. So, but in a general parallelogram, its diagonals bisect each other. Each diagonal separated the parallelogram into side angle side, side angle side, side into 4 congruent triangles. And if you look, those 2 angles in the middle, side angle side, shows that those are congruent to each other. And using this angle here, side angle side, shows that these triangles are also congruent to each other. There's 4 congruent triangles, but they're kind of like in pairs. So I think 2 pairs of congruent triangles. Because this angle that gets these congruent is a different angle than what get these congruent. Parallel, we got alternate interior angles this way, got alternate interior angles this way, but going this way, we got a different set of alternate interior angles. And going the other way, we have a different set of alternate interior angles. So we have pairs of congruent angles. So here, this is playing off on this BD diagonal bisects the AC diagonal. And they want us to solve for Z. So these 2 sections need to be congruent to each other because of the diagonals being bisectors. So 3Z minus 4 must equal Z plus 5. Take Z away from both sides and add 4 to both sides. 2 Z's is equal to 9. Z is equal to 4.5. 12.5 take away 4 is 8.5. And there's 9.5 rather. Is that right? Yeah, 13.5 take away 4 is 9.5. And 5 and 4.5 gives 9.5. Okay, here they're telling us we have a parallelogram. So we're going to have alternate interior angles. It's going to be a 33. This is going to be a 95. These 2 are going to be equal to each other. So we want to solve for x. 5x is equal to 27, since opposite sides are congruent. So x is going to be 27 over 5, which is 5, remainder 2, 5 and 2/5. 5 and 2/5, which is like 5.4. And they're not giving us any units. And for the y, this QS diagonal bisects the TR diagonal. So 2y minus 5 must equal y plus 4. take away y from both sides, and add 5 to both sides, y equals 9. So this is going to be 18, this is going to be 24. Oh, does that work? 2y minus 5, so 2y minus 5. 18 take away 5 is 13. And 9 plus 4 also gives me 13. So y is 9 and x is 5.4. Let's move on. Okay, so if we have a parallelogram, opposite sides are going to be congruent. If we have a parallelogram, opposite angles are going to be congruent. If we have a parallelogram, diagonals are going to bisect. Or one pair of sides is going to be both opposite and parallel. Those are the tests we have to see if we have a parallelogram. So let's fill this in. So if both pairs of opposite sides of a parallelogram are congruent, then the quadrilateral is a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we got opposite angles congruent. Here we're dealing with diagonals bisecting each other. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And if one pair of opposite sides of a quadrilateral is both one pair of opposite sides is both parallel and congruent, then we have a parallelogram. Let's move on. So I get some examples here. Are these parallelograms? So let's look. Opposite sides are congruent? Yes. Both pairs of opposite sides congruent. Here we got 14, 14, 180. These sides are parallel to each other. So we have a pair of opposites. They're parallel because same side interior angles are supplementary, and also they're congruent. So this is one pair both parallel and congruent. So yes, it is a parallelogram. What else could we have done there? I guess we could have done same side interior angles being supplementary and got opposite angles congruent for that one also. Here we have a pair of opposite sides, both parallel and congruent. They're marked as parallel and they're both 12s. That's also a yes. Okay, here we're showing that we have a diagonal. This is 120 degrees. This is 120 degrees. So we have one pair of opposite angles congruent, but we don't know anything for sure about those other angles. So see what we could do. Okay, here we have a pair of alternate interior angles congruent. That means that those sides are going to be parallel. Going this way, we have another pair of alternate interior angles congruent, which shows that those sides are parallel. So here we have two sets of parallel sides. That's also a yes. I think that's all for those.